So there are a few things I would like to talk about today, which is the motivation of this paper, the methodology in detecting inappropriate text, the experiments, and finally the results. So let's go with the motivations first. Um, as we know, we are increasingly using online presence and online discussions. So when we see these online discussions on Facebook, on Twitter, or whatever, we often see that the conversations turn nasty or inappropriate. And they can be rude or discourteous. It can be something that causes harm. So you ask somebody to uh, kill himself or whatever, and maybe relating to illegal activities like let's go smoke some weed or whatever. Yeah. So all these are inappropriate content, and you want to try to detect them. And the issue with this is whenever you type all this in, let's say into search boxes, into chat box, they actually learn it. And once they learn it, let's say you go to Google and you type in some content. So I'll show you. So once they learn it, if you go to Google, you type in some content like Angelina Jolie is, and then you find out that Angelina Jolie is a heroin addict. You don't want that to show up on your autocomplete. Or Christianity is fake or whatever. We don't want that to show up. So that's all inappropriate. So in conversations, what does it look like? So the offensive ones are like, oh, I hope you burn in hell. F off, American prick, or something like that. And we just want to detect them and remove them away. So the problems is that the current pattern and keyword filtering does not cut it anymore, because more and more we are using symbols, we are using misspellings and other slangs that the pattern recognition doesn't find out. So for example, you might think defecate on my face is inappropriate, right? But actually, it's very appropriate because it's actually a famous song. Yeah. But when you talk about what to do when tweaking alone, then you think it's actually quite appropriate, but it's actually not because it refers to smoke. It refers to consuming meth. Yeah. So all this we need to figure out and filter them away. So there's also then misspelling. Misspellings are basically words that are converted to lead. So as we'll see later in the Xbox gaming set, or repeated characters, short forms, remove vowels, and such things. So let's say for a bitch, they're missing an I, pattern recognition can't detect it the manual way. So what can we do? We can choose to do this differently by using detection using deep learning. And we apply this to two types of text. One is web queries, which are often short. They lack some context and semantic meaning because they're short, and they often contain many misspellings. We also apply this to conversations. So conversations often not include smileys and symbols. I think many of you like to send smileys and symbols as well. So we have to take this all into context and also the previous messages you have sent. So to detect the inappropriate text, we use this proposed algorithm by the authors called C by LSTM. And this allows us to classify the inappropriate text. This consists of three layers: a convolutional layer, a bidirectional LSTM layer, and also a fully connected layer to predict the results. So I'll go in depth over what each layer does. So first of all, we need input to the deep learning network. To do this, we use a word embedding. And because there are many misspellings, we have to deal with them. And to deal with them, we use character level embeddings. So the authors actually chose to use DSSM, which was created by Microsoft, because it was specifically trained on web search query. And the dimensionality of this output encoding is actually 300. So first, we will input this word encoding into the convolutional layer. So the convolutional layer does is to remove and to figure out the words, what the words are, because there might be misspellings, symbols, and whatnot. So this is the one that creates all the features. And in this convolutional network, there needs to be a fixed length. So luckily for web search query, there is a fixed length, and the max length for this network is actually 24 words. You can actually increase or decrease the max length, but that will take more or less weights to train the model. So next, we'll use a bi-directional LSTM to actually learn the sequential meaning of the words. This biased LSTM can actually capture long-term dependencies in both directions. So it learns more of the meaning in the whole sentence because it's very short. So it tries to learn more using bidirectional LSTM. And finally, we have the fully connected layer, which output the final class, whether it's inappropriate or appropriate. Okay, as you might know, that this cannot be applied to conversations because conversations are often very long and they don't fit into the 24-word limit. And what we can do is to remove the convolutional network and replace them with a character level input. So what this means is instead of allowing the convolution to deal with misspellings and whatnot, we allow the LSTM to deal with it by inputting by using character level inputs. But the problem with this is if you have character level inputs, then you're gonna have you're gonna run problems because it's gonna take very long to train, very long to predict. So the balance between this is to use trigrams instead of a single gram. So meaning if for a sentence like you are an idiot or you are an idiot, so you put in you followed by OU space and so on and so forth. So this allows it to be more robust to misspellings, for better prediction. So for the experiments, now that we've covered all the algorithms, we need an evaluation data set. And to obtain this data set, the authors used 9 judges to actually judge a set of word queries. And the final majority view is taken. So the authors are asked to label them as appropriate and inappropriate, and also ask them to label what kind of content they are. So they can be extreme violence, self-harm, illegal activities, race, religion, sexual orientation, or whatever, and offensive, and finally, of course, clean. So the data set contains about 80,000 sentences. So the baselines are firstly PKF, which is the keyword-based filtering. So you have to manually create all these rules, and that takes a lot of work. And that's what is being done, still being done now. So in order to create those rules, you have to first say you need to have a proper noun followed by a certain negative word for it to be matched. So this is actually very difficult and very manual work. Next is we can use support vector machines, which takes in the encoding and tries to predict the output. Or we can use a gradient boosted decision tree. So first we evaluate it on the web query dataset. And it shows that C by LSTM actually obtains the best F1 score out of all the rest of the baselines. And we can see some of the labels here, which have performed well and what has not performed well. So for example, niggerplease.com. When you place the word niggerplease together, then some of the filters aren't able to find it. But actually, the C by LSTM is able to find that it's actually 2 words, nigger and please. And this is actually inappropriate. For things like whore in the Bible. So whore is actually spelled with a W. And this is actually figured out by most of the machine learning frameworks and also C by LSTM. Other older machine learning frameworks can't find it, but C by LSTM is able to find it because it's lacking it's misspelled. So some things that are not flagged out by the C by LSTM is like, why do Asians speak ching chong? Okay, because ching chong itself is not a bad word, and it usually needs manual invention, so it needs to be placed in the pattern. So like ching chong, it's not appropriate. Yeah, so these are the things that's lacking still. So for the evaluation on conversations, the authors use Xbox dataset. So Xbox, is a gaming platform, and when you play games, you tend to get angry and nasty. So there's a lot of conversations here that are inappropriate. So in by LSTM, the model that we showed actually performed well in flagging all this inappropriate text. So what is the problem that we face when using all these algorithms? But mainly the C by STM and the by LSTM is firstly the lack of semantics, which is it can be false negative, which says that I highly doubt that you are not stupid, which is obviously inappropriate, but it cannot be flagged. Or you are the tickle to my pickle. So all these are quite coded words or sentences that the network can't pick out. But there are also false positives. So like they had to saw the dumbbell off. I mean, this is it's difficult to understand without context, but in general case, this is okay. And also like link me a picture, I cannot sleep. So I mean, if you want it, then it's totally fine, right? And there's also misspelling. So let's say you spell the word porn with PR0N. So then maybe your pattern recognition, your manual one cannot actually resolve this. But when it comes to the C by STM and the LSTM, it actually resolves it because it uses character level embeddings. And like spelling differences like stupid as fuck instead of the real thing. So in real manual cases, you can't flag it. But then actually in the deep learning case, it actually flagged it out. So there's also a lack of training data for some words because there are some urban slangs that are new that are not widely used and not actually encoded in the character embeddings. So these are like terms like coontastic, which has a offensive meaning, which I don't know what it means. I mean, if anybody knows, they can share with me. Or if your grumpy face turn up to do my house, I'll make you do it too. So like grumpy is offensive here. So lastly, there's also borderline, which what the freak I was at the pool. So this is like it doesn't seem offensive. And also lastly, there's noise, which is what authors think is they disagree with the judge's view. So using by LSTM and C by STM, we can see that these are the error distribution in the few areas. And what we see is that most of the time it's lack of semantic meaning because the web search query is quite short. There's also some noise because there might be sentences that the judges think is inappropriate, but they actually think is fine. So I think these are the two main problems with the model. But there can be also an input to this model that can be extra, like the bias, which Jiann will talk about, like the gender bias. So if there's a subject and there is a person who's receiving the comment, and what kind of things they're talking about. So if they have that subject, which is, let's say I'm a guy, I'm speaking to Jiann as a guy, and I kind of scold him or I kind of make fun of him, then maybe it's actually appropriate because it's just a friendly remark. But if I'm a guy, I'll talk to a girl and I make some remark about her, it might be actually inappropriate. So if we do include this in this model, then maybe it will be better in flagging out some of the conversations or finding all the false negatives as well. Yeah. So I think that is all. I've come to the end of the presentation.